All right, next on the list, we're going to go into another performance killer. Item 4 is giant tables versus smaller relational tables. So SQL Server is a relational database management system. What that means is that it was built to handle queries around tables with relations like foreign keys and primary keys and things like that, tables with relations really well. But what SQL Server wasn't built for was a tool to handle giant, massively wide tables. So let's say you've got a table with 150 columns in it, and they're all varchar 150, or even worse, nvarchar 150. And you've got a bunch of stuff in those tables, everything from dates to ages and numbers and strings, and I mean, all kinds of stuff that fits into appropriate data types, but it's all been put into just one giant table because that was what was easy bringing it into the system. Well, what ends up happening in that case is that anything you do to query that table, it may take a whole lot more time than you would ever expect because it's got to parse through all of that data. So for instance, if you've got a date field stored in that giant table as a varchar, and you're trying to find out where a date is greater than a specific date, yesterday or something like that, well, it's got to go through and convert all of those, either with an implicit or an explicit conversion. Either way, converting a bunch of varchars into dates is not the most optimal way to query data. So what you end up with here is really poor scalability. You end up with a ton of wasted storage, and you end up with sluggish queries, especially when a lot of those columns may be null. So real world example, table working with 150 columns, like I mentioned earlier. Most of the data types are nvarchar 150, and the table filled in at about 45 gigabytes in size. Looking at that and looking at how we could restructure it, we could probably get that table and all of those indexes to be less than 15 gig if it was structured in a way where it was broken up into lookup tables and things like that. So that gets us into how do we avoid it or how do we improve it. So this is where instead of one giant table that makes me always think of like a big spreadsheet, you break up the table into smaller pieces, and this is called normalization. Normalization is breaking up the data into smaller pieces that can then be joined to in order to be able to bring in the things you need. Denormalization is going the other way, where you're taking a bunch of smaller tables and making them into a big, massive table. And what we're talking about here is normalization, taking your one massive table and figuring out how do we split it up into smaller pieces. So for instance, let's say you've got addresses in there and one of the addresses is a city name. And if you've got 10 million rows in that table, you probably don't have 10 million city names. And city names, let's say it's a varchar or an nvarchar 100, and typically a city name might be, let's just say 10 characters. So 10 characters in nvarchar is going to take up 20 bytes, and 20 bytes times, let's say 10 million rows in that table is a huge amount of data just to store those city names. So what you do is you make a city name table, which in this example, or you can do a whole address or city-state table or something like that. But in this case, you make a city name table that has a list of all the cities, and instead of your main table containing the actual city name, you have a foreign key that links off to the primary key in that city name table. So instead of taking possibly 20 bytes for an average of maybe 10 characters per city name, and putting that in your main big table, you could replace it with a foreign key, which probably be an integer, would be a fine foreign key for that, which could come in at 4 bytes and save you a whole lot of space on every single row in that table. So repeat that for all the columns that have a lot of repeating values, even things like first names and last names. I mean, there's a lot of wild ones out there, but there's only so many first names and only so many last names out there. Eventually, if you have enough rows in your data, you're going to have repeats. And what that means is that they could be foreign keyed to a lookup table. When you do those lookup tables, you want to make sure that you use foreign keys in order to maintain relationships and data integrity there. So you can't go and delete from one while it's still being referenced from the other. And when you're working on these, you want to standardize on the right data types. So for instance, instead of a varchar 100 or an nvarchar 100 to store data that may be a Boolean, and I saw this one where we had a column that was basically a Boolean value, but it contained the values of yes, no, true, false, and on or off. So it contained 6 different values. Oh, and it had upper and lowercase versions of those as well, just to represent a yes, no Boolean type answer. So had that been something that could have just been stored as a bit instead of an nvarchar, well, that could have saved a whole lot of space, and it would have helped you with the data analysis there. If you're trying to use this data and that column has yes, no, true, and false in it, well, how are you going to compare against that? Are you going to read the text string, figure out, is it a yes, a true, or an on? And then, well, it just doesn't make any sense to do it that way. So normalize the data, standardize on the right data types, and then only denormalize when performance demands it. And if you're denormalizing for some reason, make sure you specify why so people know why. So the quick tip here is that if your table has more columns than your last spreadsheet, it's time to rethink your design.
Thanks for watching. I'm Steve, and I hope you've enjoyed this video. If you like it, please click the thumbs up icon. And if you want to subscribe, click subscribe to our channel and click the bell icon to get notified when we have new videos. All right, have a great day.